Okay.
But then, like, what I did was cos times, what's it called? The reciprocal cotangent. But I don't understand why, sine squared x, like, why is there,
Like where to go from there?
like, no, I don't understand why you put, like, a squared for the sine square x and cos square x.
Okay, with tangent squared x, you mean?
Yeah.
So, like, how do I change that one?
Yeah.
Is that what you mean?
Yeah, like, why is there a square?
So if the actual trig function is squared, if you replace it with reciprocal functions, or they would also be squared.
Okay.
So cosine would be squared, but then tangent would be sine squared over cosine squared.
Okay.
And then those would cancel, and it's just sine squared.
And then, is question 14. I got to the part where it's like tan squared x minus secant squared x.
So you gave, like, denominator?
Yeah, over tan.
Okay, so this would be tan squared x over tan x minus secant squared x over tan x. And then they're both over tan x, so you combine them.
I understand that tan squared x minus secant squared x equals 1.
Good.
But I don't understand why it's like negative.
It's -1, right. So it says tan squared x plus 1 equals secant squared x, right? That's your Pythagorean identity. Yeah. So if you move the secant on the side with the tan, then the 1 has to go to the other side.
Oh, okay, that makes sense.
So then it's -1 over tan and then -1. So, like, we're going to do this again today, but the shortcut to moving a function from the top and the bottom of the fraction is every time you move it from top to bottom or bottom to top, it becomes its reciprocal. Okay. So then you'd get -1 times cotangent x, which is negative cotangent x.
Okay, thank you.
You're welcome.
My last question is how to solve 13.
13.
Yeah.
Okay.
Thank you.
You're welcome. All right, so different denominators, right? Like nothing to replace because they're not squareds. So if I want to combine these together, I got to give them the like denominator. Okay, so the LCD would be both 1 plus cosine and 1 minus cosine. So they're going to get multiplied by what's missing from the bottom. That one's going to get 1 minus, that one's going to get the 1 plus. So 1 times 1 minus cosine would be 1 minus cosine x. The plus comes from the middle. 1 times 1 plus cosine would be 1 plus cosine x. All over 1 plus cosine and 1 minus cosine. And at that point, sometimes in the bottom, we're going to have to multiply it out, and sometimes we're not. So I tend to wait to see after I simplify the numerator, does it make sense to then multiply the bottom out? Because, again, sometimes you want to and sometimes you don't. In the numerator, the negative cosine and positive cosine cancel out. And I end up with 2 over 1 plus cosine and 1 minus cosine. And now there's nothing to cancel out in the bottom, so I'm going to try to multiply that out. Those are opposites. They result in the difference of 2 squares, so I get 2 over 1 minus cosine squared x. And that goes back to your Pythagorean identities. So 1, or sine squared plus cosine squared equals 1. If I move the cosine on the side with the 1, I'd get sine squared equals 1 minus cosine squared. So 2 goes over sine squared. And then when I bring sine to the top, it becomes its reciprocal function, which is cosecant. Any other questions on the homework before we get called down? Yeah. All right, so 12 says perform the multiplication, use fundamental identity. So it even tells you, like, to start, you want to multiply. Were your numbers 2?
No, mine were 7, but when I put 49 cosecant x the second minus 49, like, I didn't know how to simplify that any longer.
Oh, wait. Okay, let me work it out. So you FOILed it out? Yes. And you got 49 cosecant squared x minus 49 after you FOIL it out, right? And then because 49 is there twice, you can actually take it out. Or, well, yeah, I could take it out. You could have also taken the 7s out from the beginning, but it's probably more obvious to do it now. Take out a 49, and I get cosecant squared x minus 1. And then cosecant squared and a 1 are in my Pythagorean identities. So if you go back to your Pythagorean identities, it's 1 plus cotangent squared equals cosecant squared. So if it's cosecant squared minus 1, then I can replace it with cotangent squared. You're welcome. Any other ones? Mm-hmm. All right, so 2 says match the trig function with its simplified form. So let's say it wasn't multiple choice. Obviously, I'd want to be able to get there by itself, but all right, so cosine obviously stays as cosine. 1 plus tangent, that's in your identities. Oh. All right, so this one said cosine times 1 plus tangent squared. 1 plus tangent squared was in your Pythagorean identities. 1 plus tangent squared equals secant squared. So then if I rewrite that as cosine of x times secant squared of x, and secant is 1 over cosine. So this would be cosine x times 1 over secant squared x. I'm sorry, 1 over cosine squared x. One of them cancels because there's 2. Yeah, so then it's 1 over cosine, which is cosecant. Which is secant. You're welcome. All right, so the good news about chapter 7, section 2 is you already know everything you need to know, okay? It is this entire reference sheet again. The difference is that this time you're going to get a goal. To be honest, I think these are easier because you know when you're done. You're going to get a statement that says this equals this, and your goal is to get the left side to equal the right side. They are always going to be right, so it's not like you can jump to the bottom and just rewrite one of them to be the same as the other side. You have to show the steps to get from one to the other. So if you're one of those people that loves the mental math and likes to do the minimum amount of writing, today's not going to be your favorite, okay? In order to get credit for these, you do have to show all the work. Having said that, tonight's homework is a PDF, so it's not like on WebAssign, because obviously that would be you would know what the answer is when you get there already. It's a PDF in which you'll show your steps. And we're going to break 7-1 down between today and tomorrow. Tonight's assignment, you'll be able to do the whole thing. It's only 7 questions. You'll be able to do that one, and then we'll do some more over the weekend. So some tips, and again, it's not always a step-by-step process. It's not always in this order. But usually you're going to work with the more complicated side first. If there is one term on one side and then a bunch of stuff on the other, obviously you've got to break down the other side. They call it decomposing it. If you see it written in if you look up a worksheet with extra practice, they'll say decompose this into that. It just means break it down. If there's factoring involved, obviously you want to look to see if can you factor something just like we did yesterday. Usually if there are trig functions that are other than sine and cosine, we're going to write them in terms of sine or cosine, so reciprocal functions, stuff like that. And then you're definitely going to end up using those Pythagorean identities. So that's your sine squared plus cosine squared equals 1. Remember, if you divide all of that by cosine, you get the next one, which is tan squared plus 1 equals secant squared. And if you took the original one and you divided everything by sine, you'd get the last one, which is 1 plus cotangent squared equals cosecant squared. It is on that reference sheet. The more comfortable you are with it, the easier it's going to be for you to spot them and substitute them in. You don't want to have to check back and forth on that reference sheet for every question. Kylie.
Did you know yet if we're going to get the reference?
I don't know. I would say odds are probably yes, but I don't know for sure yet. We don't know for sure yet. All right, that's it. So we're just going to work through some examples. Example 1, obviously when you're looking at this, what's more complicated, the left side or the right side? The left side. So I'm going to start to work on that. So pretend the right side's not even there yet. Obviously, I know I eventually want to get to sines, but if it was just the left side that was given to you and you're looking at only the numerator, what's there that you might want to go back to check? The Pythagorean identity that involves secant and 1, right? Which is that 1 plus, or tan squared plus 1 equals secant squared. So if the 1 has been moved over to the side with the secant, then tangent is what's left. Now, I want to eventually get to sine, so is there a way to rewrite tangent in terms of sine? Sine squared over cosine squared. over what would be in the bottom? There's two things you can do here. I can leave it as 1 over cosine squared, or remember shortcut, bring it to the top as its reciprocal function, so you could have done that too. Eventually, I'd want to get it to the top, even if I had to do keep, change, flip. I would want to get it to the top, and then my cosines are going to cancel out, and I get sine squared x, which is my goal. Last step, you always want to rewrite the left side equals the right side.
So you get the left side to
Not always left, but oh yeah, to get the left side to equal the right side, but you got to figure out sometimes you're going to be working different sides. Thank you.
So this is like
Thank you.
the same thing except.
You actually know what the answer should be.
Oh, okay, they're just like practicing the other one.
Yeah.
Okay, that's good.
On the quiz or test, would we have the right side, like what we should?
Some of them. Yeah. All right, 2 sine squared plus cosine squared over cosine squared times secant squared equals 1. What's more complicated? Left side again. What's sine squared plus cosine squared? 1 over cosine squared secant squared equals 1. What happens if, well, there's a couple different ways to do this. What could we do next?
Put the denominator as cosine squared times 1 over cosine.
Okay, so I could rewrite it in the denominator as its reciprocal function. And then they cancel out, and I get 1 over 1, which is 1. You could have brought them to the top as the reciprocal functions and then done the same thing. So it doesn't matter in what order you do that. Questions on that one? All right, go to 3. What's one way to start it?
Changing the secant?
I can change the secant by bringing it to the top.
Yeah.
Yeah, I can make it 1 over cosine and then keep, change, flip it. Or I could bring it to the top. Remember, shortcut is if I move them top to bottom, they become the reciprocal functions. So if I move secant to the top, it's now what? Cosine. Then what? Tan is the same thing as? Sine over cosine. And then? Cosines cancel. About a lot of these, some of them there's like really one streamlined way to do it, but a lot of times there's gonna be multiple ways to do it. So like let's say, and God knows you guys work together on homework, that's just fine. If you're talking to a friend and they're like, I did it this way and you did it a completely different way, it doesn't mean they're right or wrong. There's different ways to do them. Sometimes it's like a very obvious path, but sometimes there's completely different ways to do them. As long as in the end you get the left side to equal that right side, and the steps in between are right, like you're doing the right, the theorems and stuff are right in between, it's totally fine.
How would you get cosine of x times tangent?
So when you bring secant to the top, it becomes its reciprocal function. It's a shortcut. The long way around would to make that 1 over cosine x and then keep, change, flip it. But the shortcut is if it's just a function, it can't be a part of a sum or difference. So I can't have done that if it said secant x plus 1. But if it's by itself and you move it, it becomes its reciprocal function. You're welcome. Okay, go to 4. What do you see there that you want to look at? 1 plus cotangent squared. Again, any kind of squares with a sum, whether it's 2 functions added together or it's a function with 1, I immediately go to my trig identities. And 1 plus cotangent squared equals what? Cosecant squared. Then what?
Change cosecant.
To be?
1 over sine.
Good. And then the signs cancel out. All right, go to 5. Now, when you look at this, I feel like it's not as obvious, like which is more complicated than the other, right? But usually if there's a sum or difference, and then the other side doesn't have a sum or difference, I want to work the sum or difference side to try to collapse it into 1. The other thing is that the left side has sine and cosine, and usually we're trying to get to those terms, whereas on the right side of the reciprocal functions, one of the reciprocal functions is there. So go to the right side. They're not squared, so I'm not going to mess with my Pythagorean identities, right? But there is a reciprocal function there, right? Secant becomes what? 1 over cosine minus cosine. If my goal is to get this to be one fraction, how do I do that? I need the common denominator, so I'm going to multiply this by cosine. I'd get 1 minus cosine squared x over cosine. What is 1 minus cosine squared x? Sine squared x, right? It's your Pythagorean identity. Sine squared plus cosine squared equals 1. If I move the cosine to the other side, 1 minus cosine squared would give me just sine squared. And then left side equals right. Yeah.
So we know that the right side is harder, but since we're working on the right side, we know the left side is the final answer. Like there wouldn't be a side where we have to work on both.
Correct. I mean, sometimes you get to a dead end and you do have to work both, but not usually. Yeah. Lucas.
I mean, just this question might seem basic, but when do we use sine squared x versus sine x squared? Like,
You never use x squared.
okay.
Yeah, it's always, and it's weird, but the trig function is actually squared. Yep.
So you can only work on like one of the sides. So you can't make the left side.
Usually you pick one, and usually you can get to the end with one. There are exceptions to that, where like you get to the end and there's nowhere to go, and so you have to work both sides.
Okay,
Yeah.
Thank you. Next question.
Yeah.
If the denominator was cosine x squared, would you turn the whole like fraction into tangent?
You could. Yeah. Yeah. All right. Next one. What would you pick?
The left.
The left. Okay. So what would you do?
You convert what's on the bottom to 1 over cosine x minus sine over cosine x.
Okay. Then I can combine those, right? They have the same denominator. 1 minus sine of x over cosine of x. Then what?
Pythagorean identities?
They're not squared. So if they were squared, yes, but that sign's not squared, so I can't.
Can you flip that?
It's a complex fraction, right? So I can do keep, change, flip. So I can do times cosine x over 1 minus sine of x. It's gone from the bottom, and 1 times that is just that. Now what?
1 minus sine of x
Is what?
1 minus sine of x is that one of the Pythagorean?
Because it's not squared. It's not. If it was squared, yes, but because it's not squared, it's not. So here's a perfect example that we got to a point that there's really nothing else I can do with that. You could actually take that and multiply by the opposite of the denominator. I could do 1 plus sine in the top and the bottom and work through it that way. But you could also then say, shoot, I'm stuck.
Can you just work on
Go to the right. What can I do on the right?
you can make secant 1 over cosine.
Okay. Then they have the same 1 plus sine of x over cosine of x. I'm so close, but it's not the same thing, right?
Cross multiply.
It's a great question. You cannot cross multiply. So when you get to ones that have just one fraction on either side of the equal sign, that would be totally your innate thing. I could totally cross multiply. But we know that answer is going to work. If you have an equation on either, or a fraction on either side of the equal sign, you cross multiply, you should get the same answer. So you can't cross multiply. So you have to go back to what I was saying before. There is, and normally I would have done it from the bottom now that I know to do it, and hopefully you'll remember too. When I get to the point in which it's only sines and cosines, nothing squared, there's no reciprocal functions, and there is something in the bottom I need to get rid of, I'm going to multiply by the opposite of the bottom. It goes back to kind of like rationalizing a denominator. If you remember your conjugates, like we got rid of things that way, you're going to do the same thing. So if I take the left side and I multiply it times 1 plus sine x, and it seems weird, but now that you see it, hopefully you know that this is an option. I'm going to distribute my numerator. Actually, I'm going to leave the numerator for a second, and I'm going to get cosine of x times 1 plus sine of x over what happens if I multiply 1 minus sine and 1 plus sine? I get 1 minus sine squared. What is 1 minus sine squared? Cosine squared. And then one of the cosines cancels out. And my left side equals my right side.
Wait, how did you get cosine squared
On the bottom, 1 minus sine squared is the, well, the initial one is sine squared plus cosine squared, right? Equals 1. So if I move the sign over, then it's cosine by itself. That is not, I wouldn't say that's like a common one where you have to leave, you get to a dead end and you really can't replace anything. But if you find that you can't replace anything or substitute anything in, then that is your option. If you have an expression in the bottom, you can multiply by the opposite of that expression. Yep.
So for this,
Actually, if we didn't though, okay, so that's actually a really good question. If we didn't and we were here, let's say, this is also a trick that people tend to forget. If you have a fraction that's already combined and the numerator is your sum or difference, but there's only one thing in the bottom, I can actually split this into two fractions. Like I can decompose it, and I can make that 1 over cosine x plus sine over cosine x. As long as they both get the denominator, and as long as the sum's in the top. I can't do it if the sum's in the bottom, but if the sum is in the top, I can do it. And then 1 plus cosine x is secant x, and sine plus cosine x is tangent x.
so either of those are right?
Yeah. Yeah, like I would give credit for each.
Oh, okay.
If it said, like if you're working obviously and it's multiple choice and you have to get to secant x plus tangent x, then you had no choice. God bless you. You would have kept going.
Okay, that makes sense. Thank you.
You're welcome. All right, go, what am I on? 7. This time I'm going to work what?
Right.
Did you start it?
No.
Oh, okay. I would go right. I'm not saying you're wrong. Like you could have changed it to like what, 1 plus tan squared. It could have gotten interesting from there. But I would have picked the right. So the right has 2 fractions. That's why. I know I have to. I can condense those. How am I going to condense them?
Multiply by the opposite.
Good. I'm going to multiply by the other's denominator. So 1 plus sine of x plus 1 minus sine of x over, this would be 1 minus sine of x times 1 plus sine of x. This should look familiar because this is like one of the ones from the homework last night. Sine and negative sine cancel out, and I get 2 over, I'm going to FOIL out the bottom. It's a special product, so it would be 1 minus sine squared x because it's the opposites. What is 1 minus sine squared of x? Cosine squared of x. And what happens when I bring cosine to the top? Becomes secant. All right, what's happening here?
Do left first.
Do the left. What's happening on that left side?
You should convert tan to sine over cosine.
Okay, you can. It's going to get messy, but you totally can. What is tan squared plus 1? It's secant squared. If you remember the trig functions, the two c's go together. No, it's not. She's not right.